Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to explain the last part for chemistry Regent for June 2018, and that's part C. Okay, question number 66, 16 through 69 lay on that table. So you have a predicted element, Eka aluminum and Eka silicon, and he give you the density at standard temperature and pressure. He giving you the melting point, oxide formula, approximate molar mass. So the first question identify the phase for EA at 310. So EA, here it is. I'm looking for the phase at 310 Kelvin. Here he giving me the melting point in Celsius, so I have to convert it to Kelvin. So I'm going to use a formula. The formula is Kelvin equal to Celsius plus 273. The melting point was 30 plus 273, giving me 303 Kelvin. So that's the melting point. So we're asking at 310. So that's higher than 303. Means less than 303 is going to be solid. Starting from 303, I have solid plus liquid. So in 310, that's liquid form. That's the liquid form. Question number 67. Write a chemical formula for the compound formed between EA and chlorine. So the EA, if you're looking here, what's its oxidation number? Here the oxygen is negative 2 times 3, and here is 2 times x equal to 0. So 2x minus 6 equal to 0. So 2x equal to 6. So x equal to positive 3. That's the oxidation number. Mean it needs 3 chlorine. So I'm going to say EA chlorine 3. Okay, identify the element that Mendeleev called Eka silicon. So Eka silicon, I'm looking here for its approximate mass, which is 72. So I'm looking for the atomic mass. So I go for the reference sheet. I'm starting looking for 72 atomic mass. So if you're looking here, that's 10, 12, 14. So I'm go on 72. So 72 here, it's almost gallium. So it's Ge. It's Ge. Okay. Now, show numerical setup to making the calculation percent error. So I'm looking here the percent error. The percent error is the formula. That's the one I'm going to use. So measured minus accepted over accepted times 100. Now, in the question, he's telling me that the ES, the measured one, is 5. Asking about the density. So 5.5. So now I need the accepted one. I know that's GE. So I'm going for the GE. Here is these tables looking for the GE. GE, germanium. So the density is 5.3234. So I'm going to say minus 5.3234 divided by 5.3234 times 100, which is that's 6.697 1 times the half. Okay. Question number 70 through 73 relate on the reaction and the formation for methanol from carbon dioxide and H. Now, it says the organic compound to which the product of the forward, so that's the forward reaction belongs. So look here, I have OH. I'm looking for the reference sheet, the functional group. OH means alcohol, so alcohol. So this is belong to alcohol. Now compare the forward rate at equilibrium. So at equilibrium, the rates are the same. So the forward reaction equal to the backward reaction. Explain in terms of collision theory why increasing concentration of hydrogen gas is in this system will increase the concentration of methanol. So increasing the hydrogen increase the probability of the collision with carbon dioxide, increasing the forward reaction and the formation for methanol. See the effect on the rates of both if no catalyst forward and backward. So the catalyst speed up the reaction on both direction, forward and backward. So if I'm going to remove the catalyst is going to lower the rate. Why? Because catalyst decrease the activation energy. So without the catalyst, I'm increasing the activation energy, and that's going to slow the rate. Slow the rate for forward and backward. From question 74 through 76, and he want to write the on 74, write the molecular formula for linoleic acid. So I have carbon, I have hydrogen, I have oxygen. So I'm going to start to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So C, 18. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and oxygen 2. So that's the molecular formula. Okay. Now, identify the type of bond between oxygen and hydrogen. The type is covalent. In another way, it's polar. Why? Because oxygen is 3. If I remember, 3.2, and the hydrogen is 2.2. So if you see the difference, which is 1 is more than 0.4 and less than 1.7. That's for ionic, and that's for non-polar. So the mid part is going to be for polar compounds. Now, you wanted to circle the organic acid functional group. That's the organic acid functional group. If you don't know, you can go for the reference sheet, and you're going to see here the organic acid here. So I need, this is a functional group C double bond OOH. Question number 77 through 79. Balance the equation. So when I balance the equation, I'm looking for balancing oxygen. So here oxygen is 2, here is 1. So I'm going to write 2. What happened here? The hydrogen being 4. Here it's 2, so here it's 2. 2 times 2 is 4. So the final equation is 2H2 plus oxygen, giving me 2H2O plus energy. Just balancing the equation. Determine the change in the oxidation number for oxygen in the operating fuel cell. So what happened here? As its element, its oxidation number is 0. Now here it's -2. So it's changing from 0 to -2. Question number 79 is set the number of moles of the electrons gains when 5 moles of electrons are lost. So what's going to happen? You have conservation of electrons. Conservation of energy of electrons means the electrons never destroyed, never created, but it's transferred from one element to another or one atom to another atom. So since it's being lost 5, so it should the other atom should gain 5. So it's the same number. Now question number 80 through 82. We have different solution WXYZ with different concentration 1.1, 0.01, 0.001. The first question 80 say the number of significant number for solution Z. So solution Z we have decimal point. So where is the first significant number? This is a 1. Count to the right, so 1 and 0, so it's two significant number. Determine the concentration of an HCl aqueous solution that has pH value for 4. So the pH equal to 4. So the hydrogen concentration is 10 to power negative pH. So it's 10 to power negative 4. That's concentration. Now determine the volume. So I'm going to use the formula for titration. It's over there, the last page, giving me molarity of acid times volume of acid equal to molarity of base times volume of base. Now, he wanted to determine the volume for the base, so the volume for the base equal to molarity of acid times volume of acid divided by molarity of base. The molarity of the acid is said solution X. So solution X is 0.1. Okay, and the volume is 75. Now divided by 0.25. So doing that calculation is going to give you 30 milli. So you need 30 milliliters. Question number 83 through 85. So we have here solubility of calcium carbonate versus the pH of the seawater. Now, the first question he asking you state the trend of the solubility of calcium carbonate as the seawater becomes more acidic. More acidic means less pH. So he wanted to go to that direction. So by going in that direction, the solubility increase because it's inverse relationship. The second part. Now, he wanted to know the color of bromocresol green in a sample. First, I have to know that solubility. So it's 10 to power negative 2. So the pH equal to 2. Now I'm going for the table for the reference sheet, trying to figure out bromocresol blue. Bromocresol blue. So here is a bromocresol blue. What's bromocresol green? Oh, bromocresol green. So bromocresol green is here. So the pH. So I said the pH is 2, so it should be yellow. I think I made a mistake. I did a mistake. So let's read the question again. Say the color from bromocresol green in a sample, which is okay. So I have first, sorry, to use a graph. It said has calcium carbonate solubility is 10 to power negative 2. So 10 to power negative 2 is here. So if you're going down, it's almost 6 point something. And after that, when I go for bromocresol green, so it's 6 point something. So it's more than 5. So it should be blue. It should be blue, blue, blue. The last question, a sample of a seawater has a pH. Determine the new pH if the hydrogen concentration increased 10 times. So the hydrogen concentration is going to be 10 to the power negative 8. Now when I'm multiplying by 100 times, it's going to be 110 to the power negative 6. The pH is negative log concentration is going to be 6. Okay, that's the end of for that part. Hope you understood. Assalamu alaikum wa rahmatullahi wa barakatuh.